Okay, I'm going to explain each part of what we did in lab. The first one was using the volume method. We measured the volume by water displacement a la Archimedes. And the sample we're using throughout the 5 parts is lead. And you have 4 other samples you're going to need to be dealing with: aluminum, iron, brass, and copper. The standard density of lead is 11.3 grams per cubic centimeter. So when I massed it in air on the scale, I got 346 grams. By water displacement, I got 31 mLs. By dividing the mass by the volume, I got 11.2 grams per ml, and the specific gravity then was 11.2. Okay, so you would then proceed to do all the other samples by this method. Then, if you're dunking it in water, what happens, we know it'll mass less because of buoyancy. So the specific gravity in that case would be the mass in air over the mass in air minus the mass in water. And when we massed the lead in water, we got 316.2 grams. So when we plugged it in the math, we got 11.3 grams per ml, or specific gravity of 11.3. Pretty good, right on. Now, we want to move to measuring the density of a liquid. You can't do it this way because most liquids are miscible, which means they'll mix with the water. So what we did is we had a hydrometer that you saw. I'll bring it up over here again. This is the hydrometer. It breaks the fluid line, and it's specifically weighted so where it breaks it is its actual specific gravity. And I got 0.88. So that's the comparison we're going to use. It's a little more watery than I'd expect in rubbing alcohol, but hey. So by alcohol displacement, the alcohol simply displaces the water. It would be the mass in air minus the mass in alcohol over the mass in air minus the mass in the water. And the mass of the alcohol was 320.8. You'd expect it to be more dense than the alcohol because alcohol is less dense, hence the buoyancy would be less. When I did the calculations, I got 0.86 for my specific gravity, which is fairly close. I repeat this with another sample, either aluminum or iron or brass or copper. Lastly, we have part 5, and this is where we have a sample less dense than water. And so we used the cork. We had 4.7 grams, and when we measured the cork in air and the mass in water, we got 19.7 grams. Ideally, it should be the mass of the cork in air and this mass, but it's a little less for whatever reason. Then I had everything in the water, and I got 299.3. The second time I got 300. I used the first value. And when I plugged it into the equation, which is the mass in air over the mass where the cork is in air and the sinker is in the water versus everything in the water, I got a specific gravity of 0.23.